Hey, how's it going everyone? Welcome to another video. Today we're going to be talking about a phone interview that I had with Amazon. So this was for an interview in January 2019 and it was for a position with Amazon Web Services. Now there wasn't much of a description on the job just because it's a new service and they wanted to be super secretive about it. But basically they wanted experience in distributed systems, scaling applications, and they only wanted 1 year of experience and just experience in a major programming language like Java or Python. The interview consisted of one coding challenge which revolved around binary trees. Now, if you have an interview coming up with Amazon, I highly suggest you study your graphs and trees because they love asking questions about them. So this means you should have your basic graph traversal algorithms down. You have your depth first search, your breadth first search. For binary trees, you should have in-order traversals, pre-order, and post-order pretty much down like the back of your hand. For Amazon phone interviews, they give you a text editor, which has no code completion. You can't build or run your code. So if you're ever practicing for this interview, I highly suggest you ditch your IDE and just stick to coding on a plain text editor. Now, when I go through the problem, I am going to use an IDE, but that's just so we can build and run just for demonstration purposes. Now, the problem that I was given was given two binary trees, check if they have the same in-order traversal. So I'm going to be going through an example, I'm going to be coding it, I'm going to describe how they wanted me to optimize the solution, and we're going to go over all of that. And what Amazon likes to do is they like to have you code up a solution and then they have you optimize that solution, which is what we're going to do when I do the demonstration here in a second. And since I am doing an Amazon related video, I had to rock the Amazon sweater. It's becoming pretty much a tradition now. So enough talking, let's just get into what you guys came here for, and that's coding up the solution.
Alrighty, so as I mentioned, the problem that I was given was given two binary trees, determine whether they have the same in-order traversal. And we're going to use these two trees for our example. So if we look at tree 1, the in-order traversal would be 1, 3, 5, 6, and 7. And on tree 2, it would be 1, 3, 5, 6, and 7. So notice that even though the structures of the trees are different, the in-order traversal is the same. So one way we can solve this is we can simply do an in-order traversal on both trees, keep track of those in their own list, and then compare the two lists together. So let's go ahead and start by representing these trees in code. So over here we have this tree node class, and it has an integer, which is the value. It has two pointers, which point to the left and right subtrees, as well as a constructor that takes in an integer and sets the value to that integer. All right, now if we go over to main, I went ahead and coded this beforehand. Over here we have tree 1, which has a 5 at the root, and we have tree 2, which is the tree that has a 3 as its root. Now, if this doesn't make sense, or if you want to just validate that these trees do match the diagram, go ahead and pause it and do that now. So if we come down here, this is going to be a private void method. So we have private static void in order. Now it's going to have two parameters. It's going to be a tree node, and it's going to be a list that we're going to be using to store the values as we are traversing. As with any traversal that we're doing, we first need to check if the tree node that we're on is equal to null. And if it is, we're just going to go ahead and return nothing. Next, we need to recurse on the left subtree. So after we return from the left subtree, we're going to go ahead and add the current node that we're on to the list. And we're not going to actually add the node itself, but just the value of the node. After that, we're simply going to recurse on the right subtree. All right, so if we go back to our main function, we're going to now need the two lists that we use to store the values of the trees. Next, we need to call our in-order function on both of the trees. So the last thing we need to do is compare the lists. So what we can do is go list1 dot equals list2. And we can go ahead and print that out. All right, so now if we go ahead and run that, we see that the two trees in fact do have the same in-order traversal. Let's go back and change one of the values just to make sure that it returns false. We see down here that it does return false. Let's go ahead and change that back to a 7, and let's go ahead and actually comment one of these nodes out. If we go ahead and run it again, we see that we do get a false.
Alright, so at this point we have a working solution, and it's a pretty good solution. However, we can optimize. And this is something you'll encounter in a lot of interviews. It's one thing to write up a solution from scratch. However, the sign of a good engineer is someone who can go into existing code, tinker it, and improve it. So for example, in our solution, instead of creating a list for each tree, what we can do is we can create a list for the first tree, and as we're doing our traversal for the second tree, we can do our check there to see if they have the same in-order traversal. So let's see what that would look like in code.
All right, so now we need to go ahead and create the method that does the check while going through an in-order traversal. So let's go ahead and create that now. This is actually going to be returning a Boolean, and we can just call it in-order check. And again, it will take in a tree node as well as a list. So this is actually going to be very similar to the in-order function. So we can actually go ahead and copy that over to our new method. We need to make sure we change the name from in-order to in-order check. Now at this point, if we get root equal to null, we're actually just going to go ahead and return a true. In between our two recursive calls, this is the point where we need to actually do a check to make sure the value in our list equals the current node that we're on. So instead of doing a list.add, at this point we need to check a couple things. If the list is already empty, we know that we don't have a match. Likewise, if we do a list.get on the first element in our list, we have to check that it equals the current value that we're on. Now, if that's not true, if either the list is empty or these values are not equal, then we have to return a false. Afterwards, we need to go ahead and remove that element because we no longer need to check against it. Now we need to do two more things. On the first recursive call, we actually need to do a check and check what this is returning. So if this is returning a false, then the whole thing returns false. Likewise, on the right subtree, we need to check whether this returns a true or a false. And we can simply just do a return on that since it's the last statement in the method. All right, let's go ahead and go back to our main method. So at this point, we are still doing in order on tree 1 with list 1. However, now we're doing an in order check on tree 2, and we're still doing it on list 1. And we can take this whole thing and print out true or false. And one more thing, we also need to make sure that our list is empty at this point. Because if we've gone through the entire tree 2 and there are still values in our list 1, that means our two trees did not have the same amount of elements in them. Also, we can go ahead and delete this line here since we no longer need a list 2. So let's go ahead and actually uncomment this here. Let's go ahead and run. We're expecting a true at this point. And as we see down here, we get a true. Again, let's go ahead and comment one of these nodes out. We go ahead and see that we get a false, which is what we're expecting. So everything looks good. Now, one thing here that I don't like is that we have to do our in order here, and we also have to check if the list is empty. I feel like this should all be done in one method. So what we can do here is we can simply create an outer method that calls our in order check. And we'll call it in order check 2. And it will go ahead and take the same arguments. And at this point, we're simply going to return in order check on root list, and then we'll do our check here to make sure that the list is still empty. And then up here, we can simply just keep this as in order check 2, and we can return, and we can remove this part where we check if it's empty. So let's go ahead and run that again. And we see that we still get a true here. Finally, with Amazon, they're always going to ask you the time and space complexity of your algorithm. So if we go up here, since initially we are traversing through every node in the first tree, it's going to be big O of n. We're also doing a traversal of the second tree, so it's also going to be big O of n plus m. Likewise, our space complexity. Now, since we are keeping a list of every element in our first tree, that's going to be a space complexity of n. Secondly, we are doing an in-order traversal on the second tree. Now, if it was a balanced tree, the space complexity would just be the depth of the tree. However, we don't have that guarantee, so the space complexity will still be O of n plus m. All right, and that's going to wrap it up for this video. Hopefully this gave you guys a good idea of what to expect during the Amazon phone interview. If you have any questions, please leave them down below in the comment section. Please make sure you smash that like button. Please subscribe to the channel if you haven't. And as always, thank you guys so much for watching, and I hope you have an amazing day.